Alright, so we have Fall 2010, question number 12, interval of convergence question. So we set up the ratio test and force it to be less than 1. We have our shortcut to divide an plus 1 by a sub n. Our shortcut is to write the terms that you have here with n plus 1's replacing n. And then in the gaps put in the associated term from a sub n and work out each individual limit. This limit goes to 1. This is 2 to the n times 2, so it's a half, and this is x minus 1 to the n times x minus 1. So we end up with x minus 1 over 2, absolute value, forcing that to be less than 1. Pulling out the half, we get x minus 1 in absolute value times a half is less than 1, timesing by the 2. We get the absolute value of x minus 1 should be less than 2. Now what that means is that x minus 1 is in between negative 2 and 2, adding 1 to all three parts. We get that x is between negative 1 and 3. We just need to check the endpoints. We can rule out half the answers. At negative 1, we plug in x equals negative 1 to our series. So we'll have negative 1 minus 1 to the n all over 2 to the n times n, as n goes from 0 to infinity. This here is negative 2 to the n, and negative 2 to the n divided by 2 to the n gives you alternating sign. It is negative 2 over 2, the whole thing to the n. So that is our alternating harmonic. It is convergent by the alternating series test. It's conditionally convergent, but at this point we don't really care about conditionally convergent versus absolute convergence versus divergent. When we get convergence, that's good enough. We don't care about the strength of it. So the negative 1 gives convergence, so we should use the square bracket on negative 1. Now we're down to find out what's going on at 3, and at x equals 3 what will happen is we get just the regular harmonic. At x equals 3, what we get is 3 minus 1 to the n all over 2 to the n times n from 0 to infinity, and that's 2 to the n over 2 to the n, which is just 1 to the n, which is just going to be 1 for us. So we end up with 1 over n, our harmonic series. So we know that diverges. We can just say it's the harmonic series. Seems to be enough. So convergence at negative 1, divergence at 3. Put these two together to get the answer is B.